and welcome back to Simple Circuits 101. This is my latest project called Traffic Lights.
Ooh, amazing!
This project simulates a standard set of street traffic lights. The sequence of lights is as follows: red, red and yellow, followed by green, then yellow, back to red again, and the cycle repeats. This is an early working prototype of the project on Vero board. Please excuse its crudity.
Oh my word, look at those dodgy solder joints.
Yes, it looks a bit messy and the components are all over the place, but it works. Now we can go about the process of improving it. Circuit diagram. So, after a number of iterations, I settled on this as the final circuit. The circuit includes the ever-popular IC's 555 timer chip and the 4017 decade counter, also used in the Cylon and Decatron videos. The 6-volt power supply is provided by 4 AA batteries in a switchable battery bank. The obligatory reverse polarity protection diode and a decoupling capacitor. These are the timing components for the 555 timer chip, and this is the pulse rate output indicator. Let's have a look at the 4017 decade counter and the role it plays in this circuit. Q12 is the carry-out output, normally used to string several decade counters in a line, but in this instance it's used to power the red LED. Output Q12 is still held high, whilst outputs Q0, 1, 2 and 3 are skipped. Output Q4 goes high and powers the yellow LED via diode D5. So at this point both the red and the yellow LEDs are on together. The red and yellow LEDs go out and the green LED comes on, which is powered by Q5 via diode 1. Q6 takes over from Q5 and maintains power to the green LED via diode 2. Then Q7 takes over via diode 3. And finally back to Q12 and the cycle repeats.
That does sound a bit complicated, but I'm sure it'll make sense in the end.
Timing diagram.
Red, red and yellow, green, 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 yellow, red.
And the cycle repeats. Construction. This is the PCB and the various components used in the project. This is a style of construction which etches only a small portion of copper away, leaving most of the copper still attached to the PCB. I'm not a fan of this type of construction. I found the mass of copper left on the PCB acts as an effective heat sink and makes soldering very difficult. By now I imagine you're fully acquainted with the classic blue tack and spit roast method of construction, and so I'll fast forward for the next bit. And press the fast forward button.
So let's place the LED, ensure the correct polarity, the lob of blue tack on there, and solder in place. It's a bit difficult, the solder. Not impressed with it. Just remove the blue tack and place the chips in there, making sure they're the right way around. Being careful not to spray the legs. And put the diodes in, make sure they correct polarity, and do the bottom diodes as well. Just true them in position. Another LED, just checking the polarity, but placing it on the under of the PCB. And solder in place. Yes, this doesn't flow. Rotate, remove the blue tack and pop in the other LED, the amber one this time. Same deal with the green LED. Secure them all with blue tack and solder just the one leg and you true in place. Take the blue tack off, yeah, it's all true nicely. Looks good, happy with it. And just solder the other side in. And that's good. Aircraft going over. Heathrow. Dreamliner. Yes, looks good. Problem with the polarity there. I grab out that and do the ident. All part of the deal. make sure the polarity is correct, and just secure that there. Looks good. This isn't soldering, but oh no! A bridge. Okay, so yeah, cut the bridge there. Cut the bridge and bit of rosin. Splob some rosin in it and use the solder wick. Just break that bridge. Really not impressed at all, this particular. But it's all part of the design. This is the first iteration. Yeah, that's okay. Disaster averted. Just neaten that up a bit. Yeah, that's okay. Close. Right, bit of isopropyl and alcohol to clean it up, and toothbrush. Give it a nice scrub. Yes, there we go. Thing of beauty. Marvellous. Yeah, so I was quite happy with that. Yes, just that last job to place the power lead in there, and blob of heat glue for security. Yeah, lovely job.
Moment of truth as I plug in the battery. Marvellous. Superb job. Yes, a rather fiddly, sticky pad, which is used to secure the 9V PP3 battery. And there you go. This is the 3D printed stand for the traffic light, and the alignment nipple.
Alright.
So this is the fully assembled project. I've removed the 9V test battery and replaced with a battery bank of 4 AA fully charged batteries, and that should last for a good fortnight or so. Yes, it's a solid design in its 3D printed enclosure, and I'm quite pleased with the results. Nice. Please note this project is not fireproof. The flames were merely added as a video effect. Thank you for watching, and if you enjoyed that video, please like and subscribe.